So, PS due at the end of the week, like I said. Quiz Friday on derivatives of exponents and log functions. The page 178, 3 through 7. No calculators. That's the quick review. That is due Friday as well. Now the note card. See where it says note card? You can put down any derivative that you want on the note card to use for the quiz on Friday. Because the derivatives of the exponential and logarithmic functions are very easy to get confused and mix them up. So you can put those down. You are also able to put down the derivatives of your trig functions if you want. Okay, because you already tested on them. You already know them. You can add those as well. The cosine inverse, I haven't decided if I'm going to test you on 3.8 and 3.9 yet. But if I do give you a test on just 3.8 and 3.9, then you can add the trig inverses on the note card as well. Make sense? Okay. Now, I'm not going to get into all of the proofs for the derivatives because we look at so many of them. They're in the book if you want to take a look at them. Tell you the truth, I don't always get to this section because they're behind, and there's some sections in Chapter 4 that I have to get to, so I don't always get to this. This is investigated more in like calc 2, right? So they'll go way more detail than I will. So I'm just going to give you like an introduction, just a generic introduction to the derivatives of the exponents and logs. Okay. So derivative of e to the x is e to the x. That's the rule. Like I said, there's a proof on page 172 if you're interested. You can look at it, go through it all, and see exactly what's going on. And what actually happens is you also have to keep into consideration is your depending on what the power is. So if I have e to the x is e to the x, that's true. Okay? But if I have some e to the u, okay, it's kind of like your chain rule. Right? So just e to the x, that's it. You're still taking the derivative of x. So e to the u, if I'm going to derive that, that is your e to the u times u prime. So u prime, remember, we have to take the derivative of the power. Kind of like when we had, if we had x squared, what's the derivative of that? It's just 2x. But then, once we had x squared plus 1 squared, what is that? That's 2x squared plus 1, and there's your 1 times 2x by your chain rule. So it's very similar to that. So if it's just a basic x, it's just e to the x, because then the derivative is that x is 1. So if we want to find the derivative of y with respect to x, where y equals e to the 2x plus x squared, that is simply going to be e to the u. So we'll represent what u is. U is 2x plus x squared. U prime is going to be 2 plus 2x. So formula, y prime is going to be e to the 2x plus x squared times 2 plus 2x. And if you want to rewrite it, what they will probably do is they'll probably bring this 2 plus 2x out in front, e to the 2x plus x squared. That's how they'll write it. Now the next one, you have x e squared minus e to the x. So if I have this right here, x e squared, how are you going to derive that? What rule would you have to use? Product. Okay? Product first. I'll show you the product in case you see, oh my gosh, I have to use product. That's fine. Okay, so you have your u prime, and then your v and v prime. I don't know why a dot won't come up. Anyways, so this is your x. This is e squared. Okay? The derivative of x is just 1. What's the derivative of e squared? Close. Close. E to the x is e to the x. Okay? So this is where it gets real tricky, okay, because e is like pi, right? Same thing if I had the derivative of pi squared. This is going to be 0. So then what do I have? I have the cross multiplying. Those are gone. I just have e squared minus e to the x, and that is your y prime. So it's e squared minus e to the x. So that's the formal proof. Okay, now I think I showed you for something else with that, whenever you have a constant. So if I rewrite this as e squared x, remember e squared is a number, 2.718 squared. Okay, so whatever it is, 8 point blah, blah, blah. So technically, this is x to the first. This is a power rule. Okay, so the 1 comes down. I have e squared x to the 1 minus 1, which is just e squared. Okay, so that's the proof of why the derivative is just e squared. All right, because it really is just a constant in front. Now here's your second derivative rule. Okay, here was your first, right here. Okay, derivative of e, and now we want derivative of a. So if we have some a, some base raised to the x power. Okay, and again, if it's just a to the x, it's the derivative of x is just 1. Okay, everyone, you got the right same thing, right? Is this on your? Is that on there? I see you guys flipping through. You don't have this rule number 2? Okay, I'll save this to the end, and I'll give you a piece of paper. We can add it. Okay, so what do you have next? You have the natural log of x, derivative of natural log of x. Okay, so we'll go to that one next. So here's the derivative of the natural log of x. So natural log, and this is, remember, the natural log, and you'll see, hopefully, in the next page, you'll see that you have a log different base. Okay, not always a base 10. It could be a log base, whatever. So this is a natural log. So this is different than an log. Okay? So what this is 1 over u, and remember this du dx is just u prime. Okay? Or how you can remember it, or view it, is u prime over u. Because du dx is u prime, u just was underneath. So if I have y equals ln x squared, identify your u. Your u is x squared. U prime is going to be 2x. So following the definition, we'll follow the definition first. So y prime is 1 over u, so it's 1 over x squared times 2x. That's the formal definition that is given in the book. To write it as u prime over u, it is simply y prime u prime over u. Can I go further with that? Yes, you can. Cancel out the x's. This x cancels with one of these. I have 2 over x is my derivative. Or 2x to the negative 1, you might see. Either one would be acceptable. Now this next one, exercise 7, you have 2 terms. So you have x ln x and the x here. So that x minus x is not part of the natural log. So since we have an x ln of x, we have to use product. So we have x ln x. Derivative of x is 1. Derivative of ln of x is 1 over x times u prime. U is x. So the derivative of x is just 1. So the derivative of ln x is just 1 over x. When I do my cross multiplying, I have these two. And what happens with those two? What do they become? 1. 1 plus ln x. And then the derivative of x right here minus 1. So that gives me a final derivative ln x. You have the log on the next page? Yeah? Okay. Like I said, I don't do this. I don't have to get into this every year. So I don't know why that one is missing. But we'll go to it. So the derivatives of log, this says log base 10, but it's any base. So there's your a. Any base whatsoever. So log base a of u is 1 over u ln of a du dx. So that is the same as u prime over u ln a. That's a little shortcut. So you see why I'm going to give you a note card? Right? These are very confusing. And to be just introduced to it, absolutely use a note card. Next year, maybe not. Okay, so what we want to do here is we want to identify. You want to identify what your u is. You want to identify what your a is. So my u will be the square root of x. My a will be 5. Right, so identify those so you know where to plug them in. Now you can see here that you need a u prime. You do not need an a prime. So here is my u. What will my u prime be? And if you need to do it on the side, that's fine. We would rewrite this as x to the 1/2. Therefore, you have 1/2 x to the negative 1/2, or 1 over 2 root x. So then following, first we'll follow the formal book definition, 1 over u root x ln 5 times 1 over 2 root x. So now you got to combine. Remember, the most difficult part of the calculus is your algebra. The numerators stay the same. What happens to the square root of x times the square root of x? It just becomes x. So then you have 2x ln 5. Now, how does it work if we use the shortened version? So for the shortened version, you would have 1 over 2 root x all over x ln 5. So you have a complex fraction. So then this denominator, you put it over 1, invert and multiply. So you have 1 over 2 root x times 1 over x ln 5, which is right there. So it works the same. Just maybe a little more difficult when you get into fractions. And that's true of any of them when you put the u prime in the numerator. So exercise 9, you have log base 2 of 1 over x. Identify your u, identify your a. What is u? U is your 1 over x. A is 2. We need u prime. If you want to rewrite that 1 over x right off the bat as your u, that's fine, because it's a lot easier to find it when it's rewritten. So this 1 over x would be rewritten as what? X to the negative 1. So you can do that right away. And then x to the negative 1, remember you have negative x to the negative 2, which is the same as negative 1 over x squared. So we go to it. We have the u prime, which is negative 1 over x squared, all over. And you have your u, which is 1 over x ln 2. So this is negative 1 over x squared, and then you have natural log of 2 over x. Would have to be written as a complex fraction because that ln of 2 is really ln of 2 over 1. So then when I invert and multiply, I have negative 1 over x squared times x over ln 2. Cancel, cancel. I have negative 1 over x ln 2 is my derivative. How we doing? So far, so good? Do you have this next with some interesting exponents? Okay. Now, if you have some weird exponents, some interesting exponents, follow your rules. Just follow your rules. So in this case here, this is just a power rule. Okay? Power rule means that the root 2 comes down, and you have an x raised to a new power. What is the rule to find the new power? Subtract 1. Root 2 minus 1. That's it. Just looks weird. Okay? It's the same thing as having just any sort of number, any whole number that we've already dealt with. Okay? Or a positive, negative, whatever. Okay? Now, it works the same way with a chain rule. So, chain rule, pi comes down, 2 plus sine 3x. What would the power of that be? What's the power going to be? By your rule. Pi minus 1. And then you have to chain it. So we have to find the derivative of that. So the derivative of 2 is 0, gone. Then remember, it's a multiple chain because the sine of 3x, that is cosine 3x, right? And then you also have to derive the 3x to give you times 3. Right, the multiple chain. So then we kind of organize this. So we have 3 pi cosine 3x, 2 plus sine 3x, pi minus 1. Okay, so just interesting exponents. Nothing has changed with any of the rules that you've already learned. Domains. So when you find your f prime of x, you also might need to state the domain. So your domain restriction for the original equation or expression will be the same plus any others in the derivative. So if this is my original expression, what is my domain restriction for that natural log x minus 4? What cannot be in the parentheses? You cannot have 0, or you can't have 4. You can't have a 0 or negatives. So remember, the x minus 4 has to be greater than 0. So therefore, x is greater than 4. That's my domain restriction. So when I go to the inverse, f inverse of x, ln of a, 1 over a, or 1 over u, okay, 1 over u I'll use, because I don't want you to get confused with log base a. So ln of u, right, so it's 1 over u times u prime. So we have 1 over x minus 4 times u prime, which is just 1. So my derivative is 1 over x minus 4, done. So if you just look at this right here, at the f prime, you're going to say the domain is all values x cannot equal 4, correct? Because that makes it undefined. But you have to take into consideration this original. So therefore, my domain, and if you want to write it as an equality, that's fine. Or you can write it like that. That's your domain. And then stay in the domain of f prime. Okay, so a lot of things to talk about here. First things first, x plus 2 greater than 0. X greater than negative 2. Domain restrictions. Okay. Now, what do we have? Remember, this is a base 10. A is 10, u is x plus 2. Our formula, we need u prime. U prime is 1. If you just have the x by itself, just x to the first is 1. No big deal. Okay? So then, remember you have u prime all over u ln a. So y prime is going to be u prime and then u ln a. And again, that's just the formula. If you don't believe me, you can turn the page back. Okay, but you don't have to memorize it. You'll be able to write it on your note card. Okay, the note cards are in your mailbox. Now, if you're talking about my domain of this right here, of the derivative, ln of 10, okay, ln of 10 is a value. Okay, it's going to be some value. It's going to be a crazy value, but all it is a value. Okay, you can put it in your calculator. You can spit out a decimal for it. Okay, so it really means nothing with regards to the domain. What matters is this right here, x plus 2. So again, all it shows me is where it's undefined. It's undefined here when it's negative 2. That's when it's undefined. So then taking into consideration my original equation, my domain is negative 2 to infinity. Good? So this is what you're going to copy on the back page of your notes. You can pause it. This looks to be the easiest, but it turns out to be the most challenging. So you have a base raised to some expression with a variable in it. So a to the u, where a is usually a number. So you have a to the u, ln a, and then du dx. So a u ln a u prime. Du dx is your u prime. So find the derivative if y equals 9 to the negative x. My a is 9. My u is negative x. My u prime is negative 1. And just follow plugging right in. AU, so it's the same as you started with. 9 to the negative x, ln a, and times negative, what the heck happened there? No, I'll say it again. All right, times your negative 1. That stunk. So then, y prime, why did that happen? Just got tired. So y prime, and if you want to leave it as a 9 to the negative x, that's fine. Okay? The negative 9 to the negative x, ln of 9. That's your derivative. Okay? Next one, a little tricky. So you have your a is 3, your u is cotan x, my u prime. You guys remember what the derivative of cotan x is. It's definitely what? We know it's what? We know it's close. We know it's negative, right? We know it's negative because it's a c. But you were close. You're very close. Remember, the c's kind of go together. Okay? So it's not secant, but cosecant squared x. So that's why absolutely put them on your note card. Okay? You were already tested on them. If you use it more in college, then you'll remember it more. So there are my values. So here we go. Where are we? There's your AU. You can look at it. I can't. So we have A. I block that off too. What is it? Cotan x ln A times negative cosecant squared x. So then the order, if you want, you can have negative cosecant squared x 3 cotan x ln 3 y prime. That one's a little tricky to do, okay, in terms of the order, but that order is fine. Even if you left it as the other order, I usually just bring the negative out in front, okay, as the leader. Even if you took this negative and just brought it out here, that would be acceptable as well. We just don't want to get confused with that negative being in the middle of the expression and thinking it's a subtraction. Okay, so that's what we want to try to avoid. Okay, and this is the last example. So we have enough time. We can copy that down. So since you're running out of time here, you're going to have to take what I put on the board for truth. Okay, so we need to derive that. So it's a y prime equals. You have 2 to the t. Okay, so there's your power. So it's your a is 2, u is t. So that derivative is 2 to the t power ln of 2, which is your a, times the u prime, which is just 1. Okay, I just threw it in there. You don't have to. Derivative of negative 5 is 0. So remember, the derivative from way back when is the equation for a slope at any point. So you have y prime equals 2 to the t ln 2. You want to find what point does the tangent line have a slope of 16? 16 equals 2 to the t ln 2. Want to solve for t. I'll bring it up here. So I'm going to divide both sides by ln 2. ln 2. So I have 2 to the t power equals 3.083. Okay, we can validate this tomorrow in class. Okay, those are your values. So then I'm taking natural log, so I have t ln 2 equals ln 23.083. Divide by ln 2, divide by ln 2. T has a value of 4.529. Okay, so that's the value of t. So it has a slope of 16. I went through that kind of quick, but if we have any questions, we can talk about it.